In this video, I'm going to review some properties of radicals that you hopefully remember from Algebra 1, but students often struggle with them, so I wanted to review them during this current chapter because we will need them in the next chapter. So we want to write each in the simplest radical form. That's something that you need to understand what those directions are. Meaning there are no perfect squares as a factor of this number underneath the radical. Meaning 24 can be broken down into a perfect square times another number. So think of the first perfect square. 1, everything can be written as a factor of 1. The next perfect square would be 4. 24 is 4 times by 6, which then can be written as square root of 4 times by the square root of 6. Now, square root of 4 can be simplified to be a 2, and the 6, the radical 6, can be written, just left alone, as a 6. And that number that we pull out, that perfect square we pull out, always goes in front of our radical sign. So the next one, 72. Think of a perfect square that goes into 72. So immediately I think of, this can become 9 times by 8. Now when you break that number down, make sure that there are no perfect squares in that other number. 8 still has a perfect square in that number. So 8 still has a perfect square in that. So we need to break that down further. So 9, 8 can be broken down into 4 times by 2. Now again, remember perfect squares can be broken out of that radical. So that 9 can get broken out of the radical and become a 3 outside the radical. The 4 can get broken out and become a 2. And then we're just left with a radical 2. Now this can all simplify into 6 root 2. Because I multiply the 3 times the 2. Okay, now with some variables underneath there. 252. If I see an even number, what I always do is I try and simplify that into 4 times a number. 4 goes in 63 times. And I'm going to worry about this k cubed in a minute. Okay, now that 4 is a perfect square, 63 can get broken down even more into 9 times by 7. That k cubed, what you want is you want it broken down into powers of 2. So k cubed can get broken down into k squared times by k. So what we have, 4 can come out of my radical and become a 2. 9 can come out of my radical and become a 3. That 7 is going to be left underneath there. K squared comes out and becomes a k. All I have left over underneath my radical is the 7. There's no more perfect squares that go in there. And the k. So my final answer, I multiply the 2 times the 3 and get 6k. Underneath my radical, I have a 7k. Now, square root of 80, x to the 4th, y to the 3rd. So, 80. Again, I start with 4. If you could see a bigger perfect square that goes in there, more power to you. Okay, and that's great. I see that 80 is 4 times 20. X to the fourth can be written as x squared times by x squared. Y to the third can be written as y squared times by y to the first. Oh, that green's really hard to see. Hopefully you can see that green. Okay, now 20 can get broken down even more. So let's start breaking this down even more. 20 can become a 4 times by a 5. And then I have my x squareds in there. And then I have my y squared. And then that y to the first, I'm going to change the color of that guy just because that's really hard to see. And y to the first. Okay, so the 4, this 4 gets broken out and becomes a 2 outside. That 4 that's kind of a purplish color, this 4 gets broken out and becomes a 2 outside. Each one of these x squareds gets broken out into an x times by an x. The y squared gets broken out into a y. What's left over? 5 y to the first. So simplifying that out just a little bit. Oh, I thought I'd be able to erase just part of my radical. Simplifying that out so that it looks nice. 2 times 2 is 4. X times x is x squared. Y, square root of 5y. Okay, so that's some of our basic simplifying radicals.